Before Faraday, before Maxwell, before anyone understood the connection between electricity and magnetism, a Danish physicist named Hans Christian Ørsted made a discovery by accident during a lecture. Watch what he saw. Here is the setup. A wire running north-south. A compass underneath. When there is no current, the compass points north, as it should. Now I close the circuit. Current flows through the wire. Watch the compass needle. It swings away from north, perpendicular to the wire. Electricity has created magnetism. The needle is following an invisible magnetic field circling the wire. I open the circuit. The current stops. The compass returns to north. No current, no magnetism. Ørsted was the first to show that electricity and magnetism are not separate forces. They are two sides of the same coin.
Ørsted's discovery was simple. A current creates a magnetic field. A compass needle moves, but that small movement contained a giant idea. If electricity creates magnetism, could magnetism create electricity?
That question haunted a man named Michael Faraday. He had no formal education. He was a bookbinder's apprentice. But he had something better. Curiosity. Faraday found the answer. A moving magnet creates electricity. That discovery, electromagnetic induction, powers this city. Every light at the compass screen, and a question.
By the mid-1800s, scientists knew two things. First, lightning is electricity. Franklin proved that with his kite. Second, electricity creates magnetism. Ørsted showed that with a compass and a wire. Ørsted proved that a current flowing through a wire makes a compass needle move. Electricity creates magnetism. That was the first connection. But Faraday asked the reverse question. If electricity creates magnetism, can magnetism create electricity? Can a moving magnet make current flow through a wire?
That question haunted a man named Michael Faraday. He had no formal education. He was a bookbinder's apprentice. But he had something better. Curiosity. Faraday asked, if a current can push a compass needle, can a moving magnet push electrons through a wire? Can we make electricity on demand, without batteries, without lightning, without waiting for a storm? Let me show you what Faraday built. A simple apparatus, a coil, a magnet, and a needle that would change the world. No battery, no power supply, just a coil, a magnet, and a question. Can motion create electricity?
Watch. I hold the magnet outside the coil. Nothing happens. Now I move the magnet into the coil, pushing it inside. See the needle on the galvanometer? It swings to the right. Moving the magnet into the coil creates electricity flowing in one direction.
Now the magnet is inside, but I am not moving it. Watch the needle. It returns to zero. No motion, no electricity. Only movement creates electricity.
Now I pull the magnet out. The needle swings to the left, opposite direction. Moving the magnet out creates electricity flowing the opposite way.
Let me show you again. Watch the galvanometer, the only needle in this experiment. Magnet in, needle right. Still, nothing. Magnet out, needle left. The direction of motion principally a direction of the current. This is a generator, a magnet spinning inside a coil. The continuous motion creates continuous electricity. Spin slowly, a little light. Every Philippines discovery powering your home.
So here is what Faraday gave us. A moving magnet creates electricity. Spin a magnet inside a coil, you get continuous electricity. This small generator lights this tiny bulb. But Faraday's small apparatus is just the beginning. Scale it up. Spin the magnet faster. Use a bigger magnet. Use more coils. And you get more electricity. Let me show you where Faraday's discovery is scaled up. Not in a workshop. Not in a laboratory. At a dam. From a small workshop to a massive power plant. This is a hydroelectric dam. It uses falling water to spin turbines. And turbines spin magnets inside coils, just like my small generator. This is Faraday's discovery, scaled up. Water falls from a height. It strikes turbines. The turbines spin. Inside each turbine, magnets spin inside copper coils exactly like my hand-crank generator. Water at the top has potential energy. It falls. That energy becomes motion, spinning the turbines. The spinning magnets inside the generators convert that motion into electricity. No fuel, no fire, just gravity and Faraday's discovery. The electricity from this dam travels down these power lines. It lights homes, it runs factories, it charges phones. All from a moving magnet and a coil discovered by Michael Faraday in a small workshop. Faraday observed the connection. He measured it. He used it, but he did not explain why. The deeper theory, the mathematics of electromagnetism, would come from a man named James Clerk Maxwell. That is our next story.